Very good morning to all of you. So, we are starting our today's lecture on physics, and from where we left yesterday. And again, just before starting, I'd again like to say all those who are sitting in the class, students, kindly now stop your chats with each other. Personal chats, you can go and chat personally, but not in this particular page. So focus over here, rest all the stuff that you are writing, so that all will be deleted and might be you will be removed from the chat. So focus on the class instead of your personal chats. Okay, good morning once again. Good morning to all of you. So yesterday we had started discussing about graphs, and I told that whenever we have a linear equation in variables x and y, then we always have a straight line, which we have discussed in a separate lecture. And then we saw that whenever we have a quadratic equation, we have a parabola which can be up facing, down facing, left facing or right facing. And these parabolas, how to trace the parabola, that also I told. Not only for parabola, for any graph, if you want to trace it, if you know that what it will look like, then after that you just need to find the coordinate on x-axis where the graph will cut by putting y equals to 0. Then you will similarly put x is equals to 0, so you will get the coordinates on y-axis where the graph would cut. And if you see that only when x is 0, y is 0 only, or when y is 0, x is 0 only, that means this graph will touch only the origin. And when we applied this concept to physics, we saw an important case of uniformly accelerated motion, where I told that time can never be negative. So we will select only that portion of the graph which will have positive time. Okay. So these were the things that we did yesterday. Now today we will be seeing other graphs and some other mathematical concepts. This is going to be very, very important. Mind it, in most of the chapters you will get graphs, and you should know how these graphs will look like, what are their properties, what are the important mathematical functions that we are going to deal today, and we are going to see in several chapters of physics. Let's see. So here, next we come to what we call as a rectangular hyperbola. So what is a rectangular hyperbola and what is the equation for this? Whenever we have two variables such that their product x into y is a constant. So rectangular hyperbola is that curve which is representing the equation x into y is constant. Now when x into y is constant, this means y is inversely proportional to x. Y is inversely proportional to x. So when we have two variables out of which you are seeing one is directly proportional to x, we say it is a rectangular hyperbola. Now mind it, here when we are taking this form, if any other form comes like y is proportional to 1 by x square, x cube, they are not rectangular hyperbola. Solely y should be proportional to 1 by x. No power of x should be present over here. And what does this mean? This means that if x we take it as 0, then y 1 upon x, y will tend to, you can never attain infinity. So mind it, we never write equals to infinity. We write going towards or approaching. This symbol arrow means approaching or going towards. So when x is 0, y tends to infinity. when y is 0, then obviously x will tend to infinity. So now here one more important thing is that x, y constant, you saw y is infinity, x is infinity. How we draw the graph? We have cases. First, x into y is a positive constant. X into y is a positive constant. If the product is positive, then just think that which quadrants are possible where x and y both are positive. Can we think of the quadrant where x and y both will be positive? If this is x axis, this is y axis, we know this is minus x, this is minus y. What are the two quadrants where you can see Lakshmita is to be removed? Again, those who have joined recently, I have told this thing that YouTube has this facility that whenever the lecture is uploaded, you can pause it wherever you want, and after pausing, what you can do is later you can hear, write, whatever you can do. Don't go for such confusion that shall we write the notes right now or not. Don't be in a haste or hurry to write notes. Listen carefully when you will again listen to the video later on, so you can pause, write those things, you can hear again and again, so that whatever points you missed out or could not understand during the live lecture, you can get that. Okay. Now look over here and tell me x into y is positive constant. I said that xy constant is called as a rectangular hyperbola. So x into y, if it is a positive constant, then what all values of x and y can satisfy this? The product of x and y should be positive. So in out of these four quadrants, where will you see the product of x and y to be positive? Please let me know fast. I am waiting for your responses. Okay, Oreo has written first quadrant. Remove Prathesh. Positive x and y, is this the only case? Think, you all are not thinking properly. If you think, you will be able to give the correct answer. First quadrant is half correct, but only half correct. Think, I have said that x into y is constant, positive constant. All are still giving first quadrant. Quadrant 3 also, yes, correct. Quadrant 3 also, beta. Why first only quadrant 3? X into y is positive constant. Two possibilities are there, na? That is x, y both positive and x, y both negative. If you multiply two numbers which are both negative, then also you will get. So correct answer is first and third quadrant. So now you saw that when x is 0, y will become how much? Infinite. When x is 0, y is infinite, means it will not touch this y axis. So I am drawing a dotted point here. Now when y is 0, x will be infinite. So you have a curve, you will trace it like this, which will not touch the x and y axis. It will go like this. Similarly, it will not in third quadrant also same way. When x is 0, y is infinite, and when y is 0, x is infinite. So these are the two portions of the rectangular hyperbola representing x into y is positive constant. Now if both are negative, then also it is correct. Both are positive, then also it is correct. So this graph will not touch the x and y axis. Second possibility is if the product xy is a negative constant. Now if it is a negative constant, that means the product being negative, So possibilities are x positive and y negative, or x negative and y positive. So this brings us again to two quadrants, the remaining two quadrants, where you can use this x y minus x minus y. So here when we have second, yes correct, second and fourth, but it cannot touch the axis. So when you say infinity, that means you cannot touch the two axes. You will touch them at infinity, means you will never touch. Yes. So second and fourth quadrant you will have, second and fourth quadrant you will have for the rectangular hyperbola, when you see or whenever you see x into y is a negative constant, and whenever you see x into y is a positive constant. So here these are the two forms, of rectangular hyperbola. Is it clear? And mind it, you cannot have any other equation as a rectangular hyperbola. If you just see that y is inversely proportional to x square x cube, don't say that sir it will be rectangular hyperbola. There can be infinite different types of curves. Every curve cannot be named or cannot be given a name, but some standard curves have been selected and they have been given name. So this is one of them, which is a rectangular hyperbola. Now can anyone tell me, if you know over here in the class, why it is called as a rectangular hyperbola? What is the significance of the word rectangular? Beta, quadrant, there are four quadrants. Gujala, listen carefully. There are four quadrants: first, second, third, fourth. Whenever you want to check, first quadrant means x and y. Just see here, x axis, y axis, both positive, first quadrant. X negative, y positive, second quadrant. X negative, y negative, third quadrant. X positive, y negative, fourth quadrant. So when I am saying that the product of two numbers is positive, so in which quadrant it is possible? Either both are positive or both are negative. The product will be plus then. And if the product is negative, means one variable is positive, other is negative. So because of that, 2 and 4. Opposite sides are equal. Beta, how can you get side? It is a rectangular hyperbola. It is a curve. How you are saying side? It is extending up to infinity. This is not the correct answer. Anyone in the class who can say? Now mind it and remember it. When any curve, you can write it in this point in your copy, we have a term which is called as an asymptote. This is called as an asymptote. Now what do you mean by an asymptote? This point you can presently write in your copy, or later if you have not written, then later while hearing the video you can again note. Asymptotes are simply the lines or axes which any curve can never touch, which can be never touched, or it will be touched only at infinity. So asymptotes are such lines or axes which any given curve can touch only at infinity, or you can say it can never touch. So can you tell me, for the rectangular hyperbola, what are the asymptotes? I am repeating again, asymptote. Vamsidhar, this is your last chance. Don't waste time in writing unnecessary comments. How many days the course is, forget that and focus on the class. Now asymptotes are straight lines which any curve can never touch, or if it touches, it will touch at infinity. So for the rectangular hyperbolas that I have drawn, what are the two asymptotes? Which are the lines which you are seeing that this curve is touching at infinity or it can never touch? Tell fast. What are the asymptotes for a rectangular hyperbola? Yes, correct. X axis and y axis. These are the asymptotes. Now, why they are called rectangular? Whenever we write x coordinate, y coordinate, if you have heard of, these are called as Cartesian coordinates or rectangular coordinates. X and y coordinates are called Cartesian coordinates or rectangular coordinates. So, why it is called? Because when you take x axis and y axis, they are mutually perpendicular. If you take any point x comma y, do you know that this will be x and this will be y? What shape are you getting over here? You are getting a rectangle. You are getting a rectangle. If you take any point and you write its x and y coordinates, then it will become a rectangle. Are you seeing the graph? So, when we have asymptotes mutually perpendicular, then in that case, we are getting what we call as rectangular hyperbola. So, rectangular hyperbola, what are the asymptotes for rectangular hyperbola? X and y axis for a rectangular hyperbola, and they are mutually perpendicular. So, they are mutually perpendicular. When two lines are mutually perpendicular, when two asymptotes are mutually perpendicular, then the graph that we get is called as a rectangular hyperbola. Is it correct? Problem with connection gone, I think. Okay, so I hope you got what is a rectangular hyperbola. So when we talk about example in physics, have you studied or have you heard of a law called Boyle's law? Can anyone tell me, in 9th, 10th class, have you studied a law called Boyle's law? Yes. So there is a law. This you will again study in first year in thermodynamics, when we have something called ideal gases at constant temperature PV is equals to constant. And moles are also fixed. Then PV is equals to constant. If you haven't studied, just see over here what I am telling. And don't say that, sir, will you teach this or not? Array, these are things to be taught. That's why I am telling over here. So right now I am telling you an example so that you are familiar with what you are going to see. Whenever you see an equation, obviously you will be seeing them somewhere. So you should be ready with, yes, what type of curve it can be. So whenever we are talking of ideal gases which are at constant temperature and moles are fixed, PV is equals to constant is called Boyle's law. If you did not study, no problem, you will again study. Now look over here, PV is constant. Pressure, P here is called pressure, and V is volume. But there is only one problem, that volume is always positive, never negative, and pressure is also positive. They are never negative. So you can see if they ask you PV graph for Boyle's law, so this constant is also positive. Now this graph, PV graph, will be a rectangular hyperbola. But when product of P and V is positive, so I told that when product of X and Y is positive, you get in first and third quadrant. Okay, Star King, you are in class 8. Kindly send Star King back to class 8. Okay, remove him from the chat. Non-stop he is writing the same thing. If you are in class 8, better when you are in class 11th, come back. Right now you can go there. Remove Star King. So here, beta, you cannot draw Oreo 13x. You cannot draw in third quadrant. See here, I told graph, like yesterday also I told that if you see overall graph, it can be in all quadrants, but pressure and volume can never be negative. So how can you draw in third quadrant? So you will remove that part which is in third quadrant. So you will draw only that part which will come in the first quadrant. So third quadrant is not possible here. So you will get the graph like this, rectangular hyperbola. So pressure is inversely proportional to volume when temperature and moles are kept fixed. This is called as Boyle's law. It is an important. Gujala Charanya, how can you draw third quadrant in this case? Please, I want to listen. I want to hear from you. I am very eager. How will you draw third quadrant when pressure and volume cannot be negative? How can you draw pressure and volume negative when we know that both are positive? If you are listening to the class properly, at least use your common sense that how can pressure and volume be put in third quadrant when we know that they are always positive. So here, please don't waste time, think here. Okay, and Vardhan, you can draw, best of luck beta, do the same in NEET and then later say that sir I did this mistake and now I am getting negative marks. Fine. So I am continuously telling, repeatedly you are telling nahi we can draw. Okay, best of luck, keep on drawing in third quadrant. I hope for rest of the students it is clear. Example of rectangular hyperbola. Now we move to next important set of graphs. We are going by the standard equations. Next is a circle. Circle standard form is x square plus y square is equals to r square. Here r will denote radius of the circle, and in this case center of circle will be at origin. So when we have an equation x square plus y square equals to r square, we say this is a circle whose radius is capital R and this is the equation. So this, if you see, the points where it can cut, this is the center at origin, this becomes the radius. Now you can see 4 points where the graph is cutting the axis. You can very well say that if there is any wrong, you can make it correct. I am presently teaching here. I am not here to make things correct or wrong. And I am telling repeatedly that it is not correct. Still, if someone is writing, yes, it is, can be done. So, beta, don't expect anything that if you are non-stop, you are keeping on telling, no, I can draw, I can draw. So, I said, best of luck, draw it. So, this is not a moral lecture going on where you are suggesting me what to do, what not to do. I am teaching here. My job is to teach. If you are not sincere, you will be listening something from me which you may not like. And if you are sincere, I will always appreciate your efforts. That is me. I cannot change myself. Very sorry for that. Now listen over here. Okay, don't say sorry or something. Instead, while things are being taught, focus on the class instead of wasting time in writing comments which are of no use for the class. Learn something, what is being told to you. This later on you will find these are very useful to you. And one day you will be definitely thanking me that yes, these are the things. Yes, I am rude. That's why I am rude. I am very happy with that. Are you going to do anything about that? Who is this Jhadu and all, what name I don't know you are having. So if you feel I am rude, fine. I am very happy with that. So some things can't be changed, so I cannot change myself, right? Where I am happy, what makes me happy, I'll be happy by that. I am happy in teaching. I want to transfer or make you know something, impart knowledge to you. If you are ready to accept it, be my guest. If not, then kindly you may leave the class. But don't distract others by writing random irritating comments. So coming back. So center of circle is at origin. Now if you see where the graph is cutting, I have told the method, put x is 0. Beta, if you will put x is equals to 0, you will get y square is r square. So y square being r square, that means y will have two possible values, plus and minus. And if you put y equals to 0, you will get x square equals to r square. That means x will be plus minus r. So that's why you can see the points. This point x is equals to plus r, means r comma 0. This point will be minus r comma 0. This point y axis 0 comma r, this point will be 0 comma minus r. So this is a circle. This is a circle whose standard equation x square plus y square equals to r square. In general, remember what will happen in this form. If you see the coefficients of x square and y square, they are same. Remember, coefficients of x square and y square are same. Example, sometimes I can give you like this also, say 3x square plus 3y square minus 1 is equals to 0. This is also a circle. If you see, this is also a circle. Why? First of all, you have to bring it in this form. See, what we can do from here, you can take 3 common, x square plus y square, minus 1 you can take on the other side, becomes plus 1. So from here, you are getting x square plus y square is 1 by 3. So this means it is also a circle of center at origin, and if you see, this 1 by 3 becomes r square. So its radius r is 1 by root 3. So in general, yes, correct, x square plus y square is 1 by 3, correct. So x square plus y square is 1 by 3, this 1 by 3 is r square. So r square is 1 by 3, r is equals to 1 by root 3. So mind it, just don't see that, sir, you told x square plus y square is r square, this is circle, but we got this form. Even this is a circle, the coefficients of x square and y square should be same. If they are same, then we have this x square plus y square can be written as, taking the term, common term on the other side, you get the radius. Is it clear to all of you? Okay. Now, what if the coefficients of x square and y square are not equal? What if the coefficients of x square and y square are not equal? Then this circle will change. If coefficients of x square and y square are not equal, I think, who is this Zamzan continuously writing the same message? Stop commenting, focus on the class. So here we have another curve which is called as an ellipse. Now this will be an important thing for you, kindly note this thing. Ellipse, it is a distorted circle. It is a distorted circle where in the equation x square plus y square term is coming, but their coefficients are not equal. If the coefficients of x square and y square are not equal, then you will get what is called as an ellipse. The radius will not be same. So here ellipse, the standard equation for an ellipse is of the form x squared upon a squared plus y squared upon b squared is equals to 1. This is the standard equation of an ellipse. X square by a square plus y square by b square equals to 1, where I said the coefficients of x square and y square should not be same. That means a and b should not be same. Because if a and b become same, then it will become a circle. If a and b are same, this ellipse will become a circle. If a equals to b and suppose I call it as say r, then it is a circle. Why? Because x square by r square plus y square by r square is 1, so x square plus y square is r square. So it will become a circle of the form x square plus y square equals to r square. So we will not take x and y coefficients as same, they are different over here. This is called as an ellipse. Now if you see here again, I know how to trace. Put x is 0. If you put x is 0, so y square by b square will become 1. That means y will become plus minus b. And if you put y equals to 0, so you will get x square by a square will be 1. So if you take under root, x will become plus minus a. So in this case, if you see the ellipse that I am talking about, how this ellipse looks like. So this is an ellipse. This is an ellipse. Now here, if you see the coordinates, it is cutting at x is equals to plus a and x is equals to minus a. Y 0, comma b and 0, comma minus b. If y ellipse will become circle. I have proved over here, beta. See here, if a and b are r, then x square plus y square will become r square. That is equation of circle. I have already proved over here. Who is this? Decons Advanced Ministry, whatever you have your name, your stage name or whatever you are using the name. I hope you got it. So that's why it is a circle if a and b become equal. So this is an ellipse. If I name these points as a dash, b dash. So here generally if you see, if a is greater than b, if a is greater than b, this a dash will be greater than b dash. A dash, this is known, this line or x axis will be called major axis, and BB dash will be called minor axis of the ellipse. So if this is large than this axis AA dash will be called as major axis of the ellipse, and if we can say BB dash, then BB dash is called as the minor axis. You cannot say that every circle is an ellipse. If it is A and B are equal, then it will not be an ellipse. It will become a circle. I hope you have not seen this, that's why you are asking the question. What I have written for ellipse, A is not equals to B. So now can you tell that it is an ellipse? So circle is not an ellipse. Circle is the limiting case of an ellipse when if I make A and B equal. If they are not equal, then that's why now we are calling them as ellipse. So if the values of A and B become equal, it won't be an ellipse. It will convert into a circle. Whichever axis, yes, if whichever axis is larger, it will be called as the major axis. Generally we take, if you see the standard form, I have written over standard equation. Generally when we take the ellipse, major axis is taken as x-axis, but you can take the opposite also, whichever is larger. Understood? Yes. Who has written Seshacharya? Yes, whatever you have written, that is a second degree conic equation. That is also a circle where circle's center will not be at origin, it will be at some other points. Why A is large? Yes, this is also a circle equation. Seshacharya, Seshu, that is also a circle equation which you told. That is also circle equation, but whose center is not at origin, it is at some other point alpha comma beta. So I have written over here, and if you see yesterday's class when I started, I am just focusing on the standard equations. Second degree conic equation is of no use to you, otherwise I would have written. Again you are writing the same thing, I know that better, please you can stop writing that comment again and again, I know that thing. If you see the entire equation, it is not only x square plus y square, it is ax square plus by square plus 2gx plus 2fy plus c equals to 0. Okay, all figures don't have their center at origin, they can have at other points also. So I am focusing on the standard equations which will be suitable for you. These are mathematical tools which will be helpful for you. Okay, so here we will say that these standard forms are going to appear in physics, what you are going to study for NEET. So second degree conic is not, general equation is not required for you all, that's why I am not discussing that. If it is required, then I will definitely discuss everything. So presently focus on the things that are of importance, major axis, minor axis. Now if you see AA dash, I said is major axis, BB dash is minor axis. So yes, it is related to Kepler's law, correct. Now in gravitation chapter you will study a law called Kepler's law, there you will see the usage of this. There is a chapter oscillation, simple harmonic motion, there also you will see the usage of this graph. That's why I am teaching it over here. Understood? Focus now. Then if you see half this AA dash, if you see total length of AA dash, what will be the total length of AA dash? This much length is A, this much length is A, this much length is B, this much length is B. So AA dash will be of length 2A and BB dash will be of length 2B. So A, which is half of the major axis, kindly remember this term, it is called length of semi major axis, and B is called length of semi minor axis. Length of semi major and semi minor axis. I hope Deacon's Adventist, you are not listening to the class. I have few moments back only I have told that whichever is larger can be taken as major axis. In some case, BB dash can also be taken as major axis if small b is more than small a. Focus here. So, semi-minor axis and semi-major axis are denoted as A and B. And what is the significance of this? You should know this thing that, and these two are very, very important, all comes by the usage of calculus. You are not required the derivation, but the results are directly useful because this chapter is basic mathematical concepts. These are the tools you should know. So what we have? Two very, very important things. One is area of an ellipse. If you see the entire area which is inside the ellipse, so area of ellipse is given by pi AB. And if you see the perimeter, it is pi A plus B. And here if you put A and B equal, that is R, you will get the area of circle. If you take the case when A and B are equal, both are R, then can you see it will become pi R square, it becomes a circle. And similarly, if you take A and B as R, then you will get the perimeter of a circle pi into 2R, which is 2 pi R. So these are very, very important results when we have semi-major axis and semi-minor axis of an ellipse given. The area of ellipse is pi AB and the perimeter is pi A plus B. Football anime, I think this is your last class. From tomorrow you won't be visible in the class. You have already said time out, so stay out. Now others. Look over here, pi AB, it is the area of an ellipse, perimeter is pi A plus B. Clear? Okay. So as I said, if A and B become equal, then you will get a circle. Now, after this, next we come to what we call as logarithmic function and its graph. Now what is a logarithmic function? Logarithm you have studied, or some of you, those who have not studied, listen here, and those who have studied, you should know what is log. So here, okay, again this guy, he has returned back, who has I think not got anything to do with classroom. Kindly remove him, this Moon Knight Mudassar. Okay. Logarithmic function and its graph. When you are writing something like this, how we read this first? It is read as log value of A with respect to the base B is equal to C. So when you say log, it is read like this: log value of A with respect to, WRT means with respect to, base B. This is called the base, this is A, base B, and equals to C. Now what is the purpose of logarithm? Can anyone tell me why do we use logarithm? What is the meaning of this? If I am saying log A to the base B is equals to C, what does that mean? So basically log is nothing but a mathematical way by which we can calculate the power of something. We can calculate the power of something. here atomic number and mass number. It is wrong. It's not atomic number and mass number. So log a to the base b is equals to c. This gives you power. Yes, correct. It represents power. So how we say this simply means, first it is read as log, and how we understand it, it means b to the power c is equals to a. So basically it says, no, it does not calculate big number. It basically says that what should be the power of b so that you get a. That power is calculated using logarithm. So b to the power c, this c becomes the power. So what power of b will be equal to a? This is called as logarithm. This is the simple meaning. Example, if I write 2 cube is 8. So we know what is the power of 2 which is giving you 8? It is 3. We can represent it log value of 8 to the base 2 is equals to 3. Or if they say what is log 1000 to the base 10. So suppose I take this is equals to x. This means 10 to the power x will be equals to 1000, or 1000 can be written as 10 cube. So equating powers of same base, x is equals to 3. So yes, correct. Whenever we calculate the power of something, it is called as logarithm. But there are some restrictions. There is no other form. This is the only form. Mind it. So it means this value. What is the restriction for log? Log can be calculated only for positive quantities. When you are writing log a to the base b is equals to c, here a should be always positive. You can never have a as negative. Second thing, when you are having b, the base should always be greater than 1. Beta, power should not be negative is wrong answer. You can have negative power also. Let me prove you wrong fast, not in an intention to demotivate you but to explain you. Power can be negative also. If for example, if I say log 2 what is the meaning of 2 to the power minus 1 by 3? 2 to the power minus 1 by 3 can be written as 1 by 2 to the power 3. I hope it is correct. Which will become 1 by 8. So we can say log of 1 by 8 to the base 2. Is it correct now? Shesha, is it correct now? Please check and tell. If 2 to the power minus 3 is 1 by 8, so can we write log 1 by 8 to the base 2 is minus 3 or not? So we can have log value as negative, but the restriction is that whose log you are calculating, this part, this part should always be positive, and the base that you are taking, base should be always greater than 1. Why? Because if you take base as 1, then 1 to the power whatever you will take, it will become 1 only. So it is not true for all values. You can say that, sir, but log 1 to the base 1 is 1. But log is something which should be generalized. It is not correct for any other value. So that's why we select base b which is greater than 1. We don't take less than 1. Is it clear? So very, very important restriction we have whenever we have log. Remember, log value can be positive, log value can be negative, but the restriction is that whose log you are calculating, it should always be positive, and the base that you are taking should always be greater than 1. This is a very important feature of log. Okay, now we have two important bases for logarithms. First one is called common base, that is 10. So if I am writing log y to the base 10 is equals to x, that is 10 to the power x is equals to y, it is called as common base. This value is called common base, and I am writing two important values which every one of you should remember, because this will be used in physics. So kindly, those who know, very good, those who don't know, remember. Log 2 to the base 10, which is 0.301, and log 3 to the base 10, which is 0.4771. These two are important values. These two are important values which everyone should know. So first is a common base which is 10, and you see, if you have seen a logarithm table or a chart, they always use common base. But since when we study physics, we will be studying something called calculus, branch of mathematics which deals with rate of changes or change. It is called as calculus. So in calculus, when we see the rate of change of something which is continuously changing, so one base creeps in automatically or naturally. In calculus, a particular constant value appears naturally in the base. So that is given the name as natural logarithm. So one base is 10, which is called as common base. Another base is called as natural base, that is E. Also this E is called as Napier's constant. This occurs naturally in mathematical equations. So that is given the name natural base Napier's constant, whose value approximately you can remember is 2.7. 2.71 given, 2.7. So log x to the base e is also represented as ln x. Instead of log x to the base e, you will see that in books, standard books everywhere in physics, gradually in next 1 or 2 classes when we start calculus, you will see this usage, ln x. Why this name ln? Ln is read in reverse, natural logarithm. So whenever we have the base e, it is called ln x. So if I write log x to the base or log x to the base e, I write as y, or ln x equals to y, this means x is equals to e to the power y. So it is a naturally occurring base in calculus So while calculating rate of change, it occurs naturally. So this has been given a privilege by the mathematicians as a standard accepted base, which is called as natural base. So whenever we write log x to the base e, we will also write it as ln x, and ln x is read in reverse as natural logarithm. And as I told, the base should always be greater than 1. You can see even e is greater than 1. So I will just take a moment to relate these two. Why? Because this is very, very important. In standard books, in logarithm table, you will be given 10 base, but natural logarithm is ln x. So there is an important conversion factor which I will write over here. Everyone should know this, how to convert ln x into common base. Ln x is approximately 2.3 times the log value in common base. Ln x is approximately 2.3 times log x to the base 10. So example, if you see log 2 to the base 10 is 0.301. So you can say, if I am asked what is ln 2, ln 2 will be 2.3 into log 2. Log 2 is 0.301, which approximately equals 0.693. So remember, whenever we have natural logarithm, if you want to find its value and if you know the value in 10 base, you can simply convert into natural logarithm only by multiplying an extra factor of 2.3. This is very, very important thing. Kindly remember this thing. Okay. So we'll be stopping our class over here. Prathesh, don't be the teacher. Here I am there to teach, and other teachers also, they very well know when it is time for what. Okay, so you have been given the time to study, and I hope you are not the one who is preparing the timetable. So focus on the class. I have already said that I am stopping the class now. So what important points I told, kindly read this. Tomorrow we will see numericals as well as graph for logarithmic functions. Okay, so that will be all. Thank you. Take care.